Okay, Ramika, we are live now. We can start.
Hello and good afternoon, everyone. This is Rimika, and on behalf of ForOptom team, I would like to welcome you all. Starting with short intro of our student session, which is initiated by ForOptom team, where we discuss and interact about optometry related topics. As it's live on YouTube, if you have any queries, you can type them out on the chat box, and we'll be discussing them after the presentation. Today we have Mr. Bishnu Thakur with us, who is going to discuss about interference. He has completed his diploma in optometry from Lumbini Eye Institute, and he is a currently first-year optometry student at National Academy of Health Science, Nepal. So on behalf of our Optom team and our audience, I welcome you. Over to you.
Thank you, and thank you for Optom giving me an opportunity for presentation. Today we will discuss about interference phenomena, and today content is first of all history and superposition principle, different terms and definition of interference, and then after young experiment, and then after coherence, condition for interference and application. First of all, history. Thomas Young in 1802 gave the phenomena called interference, and this interference phenomena proved the wave theory of light. And after superposition principle, the principle of superposition states that whenever two or more waves traveling in the same region superpose or overlap, the total displacement at any point is equal to the vector sum of their individuals displacement at that point. The process of vector additions of the displacement of a given particles is called superpositions. We can hear in figure, first figure number 1, superposition of two square waves traveling in opposite direction in positive x direction with the same velocity, and in figure 2 the resultant wave formed by algebraic summation of the two waves. And terms, before we go for the interference, we must know about different terms. Wave, it is a kind of disturbance which is transferred from one part of medium to the next. And disturbance, disturbance means change in pressure, density or displacement of the particles about their equilibrium positions. Disturbance is due to from waves. And after crest and trough, a crest is a particles on surface wave where the displacement of the medium is at maximum, and trough is the opposite of a crest. Wavelength. Wavelength means two symmetrical part of the wave motions. In figure, we also see wavelength means two symmetrical parts of the wave motion, and amplitude means maximum displacement of the wave from the baseline, and any portion of the cycle is called phase. And phase, when two waves of equal wavelength travel together in the same directions, they are said to be in phase if they are perfectly aligned in their cycle. Frequency. We must know frequency is the number of vibrating particle in 1 second. And phase difference. Phase difference means fraction of wavelength by which two waves of equal wavelength traveling in the same directions are out of step with each other. Then after about interference phenomena, what is interference? It is the phenomena in which two or more waves overlap so that a resultant wave is formed, whose amplitude may be greater, lower, or same as the amplitude of original wave. It is the property of light that exhibits its wave nature. And this phenomena can be observed in all type of waves, like light wave, sound wave, and matters. For example, and given shows that air bubbles shows the interference phenomena at different levels, and there is a drop of oil is sprayed on water, a thin film is formed due to due to this thin film, interference phenomena is shown, and light reflected from each other of the film. This, and after type of interference, there are two type of interference: constructive interference and destructive interference. First of all, we discuss the constructive interference. Constructive interference, when two waves of equal wavelength are in phase and travel together, they are summated to result in a resultant wave of amplitude equal to the sum of the two known as constructive interference. Maximum in constructive interference, maximum intensity is produced because the energy of the electromagnetic field is added together. And principle is used in laser. And destructive interference. In destructive interference, when crest of one wave coincide with the trough of other wave, the two electromagnetic field cancel each other's. Intensity is minimized. And for constructive interference, part difference is equal to n lambda capital D by D. And for destructive interference, part difference equal to 2n minus 1 lambda capital D by 2 small d, where n is equal to numericals 0, 1, 2, 3, etc. And wavelength is lambda is equal to wavelength, and small d equal to distance between two slits, and capital D equal to distance between slit and screen. Then after Young experiment, Young in this figure, Young set up an experiment to demonstrate for wave nature of light. A monochromatic when monochromatic beam of light is incident on a single slit, this act as source of wave front onto two slits. The coherent source interfere with each other, forming a pattern of light and dark band. And there is a for constructive interference, this pattern is formed. For constructive interference, dark fringes or bright fringes, and for destructive interference there is bright and dark fringes. For example, interference for constructive interference, when wave A and wave B are resulting for additions, when wave A and wave B are adding, then amplitude increases. And for destructive interference, when wave A and wave C are added, then the amplitude is decreases. And coherence means coherence came from the Latin meaning hanging together. Two sources derived from single source which emit light of same wavelength and amplitudes are called coherent source. Coherence describe the ability of two light beams or different part of the same beam to produce interference. Only coherent source are produce permanent interference. And type of coherence, there are two types of coherence: spatial coherence or lateral coherence, and then after temporal or longitudinal coherence. Spatial coherence means ability of two separated portions of the same to produce interference. And temporal coherence, ability of one wave of a beam to interfere with a different wave within the same beam. We simply call spatial coherence is when respect for time, spatial coherence respect for positions when phase difference is 0, and temporal coherence is with the respect of time. In clinical significance, there is a destructive interference occur within the stroma of the cornea. Most of the collagen bundles of the stroma are so spaced that any light deviated by them is eliminated by destructive interference. And what are the conditions for interference phenomena? These all are the conditions for the interference phenomena. First of all, two sources must be coherent. The interfering waves should have certain part difference. The amplitude of the interfering waves must be equal or nearly equal. Two sources must lie very close to each other. The distance of the screen from the coherent source should be larger as compared to the width of the slit. And last one, the source should be monochromatic. That is, each source emit light of single wavelength. And application of interference. What are the application of interference? First of all, it has been used by Michelson and Morley in their famous experiment. which disprove the existence of ether. And interference is used in laser interferometry, technique for evaluating retinal function in the presence of cataractous lenses. Predict visual potential in patients with hazy media due to cataract. And interference is also used in holography. Utilize the phenomena of interference to produce three-dimensional images. Three-dimensional image used nowadays in credit card and banknotes also holograph and also use interference holograph in the holographic object are used frequently in daily life like banknotes and credit cards. And after anti-reflective coating on spectacles glasses utilize the principle of interference. And then after used to determine the refractive index or thickness of transparent sheets. And point number 5, barrier filter used in fundus camera transmit only long wavelength, that is 500 nanometer fluorescent emission received by the flame. And then after excitation filter used in fluorescent angiography transmit short wavelength less than 500 nanometer cause fluorescent to fluorescent. Questions? Any question?
That was a wonderful presentation, and I'm sure our audience have also enjoyed it. We have not got questions yet, so I request you to share your experience on today's session.
Oh, actually, this is the most wonderful platform. I would like to thanks ForOptom for giving me a wonderful opportunity of sharing my bit of knowledge. This is a wonderful platform to build our confidence. And thank you.
Thank you for your kind words, and I would like to thank audience too for being supportive. This brings us to the end of the session.